All right, today we'll be doing the Session 5 lab, which is unpacking an exe with a debugger. So let's start by looking at model.exe. The first thing we're asked for is to see if ASLR is enabled, and if it is, to disable it. So we're going to go ahead and we're going to pull that into CFF Explorer. We'll go to the optional headers, and we'll go to DLL characteristics. And we have this option enabled, which is DLL can move. That's ASLR. So if we uncheck that and then hit OK, it will be disabled. And then we can go ahead and save this as a new exe. We'll just say disabled ASLR. Sure. And then we'll close that out. And then what we're going to do is we're going to put this into our X64 debugger. And let's see, empty. Oh, should have been more patient. Let's put that back in there. Okay. And so we're being tasked with to review the assembly here and to determine which instruction transfers execution to the unpacked code. So let's start by finding the unpacked code. I'm going to assume it's at the bottom. Yep, here it is. All zeroed out. And we're going to scroll up. Let's see. Where does it start? Okay, here it is. So we're going to look for a jump instruction that's ideally jumping to those zeros to the unpacked code. So these are some loops. Oh, we have a jump here. Okay, it looks like it's jumping to something that's not not packed. And this is a jump of equals. What about this one? Okay, this one. All right, so this jump, there's assembly instruction for jump model disabled ASLR dot 4014E0 seems to be jumping to a place that has unpacked code, and we can tell by just looking as we highlight over it, we can see it's those instructions where it was just zeros. So we're going to go ahead and we're going to, well, first let's set a breakpoint first, because we want to run the program and then have the debugger stop it right at the jump. So right before we can access the unpacked code. So I'm going to toggle that. And I want to do one thing beforehand. I want to just see any kind of strings that are being referenced in the program. And this is all we get. We get a bunch of question marks, some random letters. This looks like worth something, but at the end of the day, really not much. So let's see if we unpack it, if we can see more in the strings to validate that, the breakpoint that we set, the jump that we got to the point in the program where it actually unpacks the code. So let's go ahead and run this. And you can see that our RIP brings us right to that instruction where it does try to jump into that unpacked code. Now, you can see here as we highlight over this, we have a different instructions show up. We're no longer seeing those zeros. We're no longer seeing the unpacked code or the packed code. Now we're seeing the unpacked code. And so what I'm going to do is I'm going to take this jump so that we can get to the original entry point. We're going to step into, and this should be the original entry point. This should be the unpacked code that we're in. And we can validate that by doing the same thing we did before. Search for current region string references. There you go. So a lot more strings this time around. So we could definitely see that the unpacked code is now viewable. And yeah, a lot more strings here than we saw before. Yep, I just saw some WinAPI functions. Look at that. Okay, so now what we're going to do is we're going to dump the process from memory. So now that we've reached the original entry point, we can use tools like OllyDump and dump this process now that it's unpacked. And so we're going to set our OEP to our RIP since we jumped to the original entry point. And we have other couple things here, read, write, execute. Make sure we check that off as right. Check that off as right. This one's read, write. It's got that already, so we're good there. But otherwise, yeah, that's the main thing is we just want to make sure that the um, for this new executable we're creating, the entry point for it is not what it used to be in the packed sample. It's now going to be the entry point that we have discovered in our unpacked sample. So we're going to go ahead and dump that. Dump that to the same folder. Finish that. And we might have to fix the import address table. Let's see if we need to. This is the new unpacked model.exe. Let's pull that into PEBear. And let's go to imports. Okay, so yeah, it's highlighted red. So that most likely means that the import address table is broken. So what we're going to have to do is we're going to close this out and we're going to put this, actually let's open this back up, open up our x64 debug back up, and let's go to Scylla. And what do we do? Oh yeah, IAT auto search. So it's going to look for that import address table. It does find it at this address. In the previous unpacked file we had, the address for the import address table wasn't right. So it was kind of flagging that as, hey, we can't find the imports because of the import address table is not right. So then we're going to run get imports, and we're going to get rid of the failed import that it found. But yeah, you can see here we have our other libraries, kernel 32, MS, VCRT, and then kernel 32 again. And so what we're going to do is we're going to click fix dump, and we're going to point that at our previous dump file. And should be it, right? Yep. There we go. So we have now, so we had our original Model X exe. We then disabled ASLR on that one and created a new P file from exe file from that. Then we created another one that would be the unpacked version of model.exe, and then we created one with a fixed import address table. So let's just validate that that is fixed. We'll take that new Scylla one and we'll put that into PEBear. And let's check our imports. And there you go. Import address table fixed. Unpacked code. No longer packed binary. We can now go ahead and analyze it further. But yeah, all that was done obviously in a debugger. So I think that's it. Yep. All right. Thanks, Anuj.